Okay, welcome back. This video is for learning the basic settings for CURA. So at this point, hopefully our 3D printers are now fully assembled. You're going to have to do some initial settings with CURA. If you go to my website and then go to the 3D printing resources, and then if you go to the instructional videos, at the very bottom, the very last video, they show you how to set up CURA, and it's like a 9-minute video, but you only need like minutes 2 to 4 or something. It's a pretty quick setup. So since there's already a video for that, I'm gonna skip that part. And when you're done, your CURA page should look like this. When you open CURA up, you should have something like this, or you have may have another machine programmed to be the first one to come up, but if it's not, just go to machine and then start, and then because that's the name of our printer, is the start printer, and this should pop up. So this blue checkered area represents the build plate. So if you had a different printer, for example, this is a different printer. This is my other 3D printer that I built, so it's got a round build plate. So whatever the printer that we're using, it's going to represent the build plate with this blue area. So you can scroll in and out using the scroll button on your mouse. If you right click and hold it, you can move things around, and at some point you can load a model, bring it in, and see what it looks like. CURA makes it really easy to move things around, duplicate things, but the purpose of the video today is I'm just going to go through what some of these buttons mean on the side. So under the basic tab, our first thing is quality. So obviously the changing these settings may affect the quality of the print, specifically the layer height. So we know that our 3D printers print in layers, so this determines the height of the layer. So if you wanted a really nice print, you would want smaller layers, but that means that it's going to take much longer to print. If we add more layers for the printer to do, that's going to take a lot more time. So if you're just going for something quick just to see what something looks like, we may want to play with this number and make it a little bit bigger. If we want something that looks really nice, then we can make it smaller. So if you hover your mouse over the box, it'll give you some suggested sizes. In terms of our printer, I haven't messed with it enough to tell you like what the best range is, but that'll be something that we'll have to play with. The shell thickness. So the outermost layer of your object is referred to as the shell, and so the inside is usually pretty much empty space to save on plastic, but the shell is not, to make sure that it doesn't fall apart. So how thick you want the shell is kind of similar to the layer height. So if we have a thicker shell, it's going to spend a little bit more time printing the shell, and that may or may not be something that we want it to do. So thinner shell means faster print. Thicker shell means stronger and more rigid. Retraction or enable retraction. If you're building something that's has tall pillars, let's say, that are not really connected. So if you imagine like printing a Lego piece, but maybe bigger, the little cylinders on top of a Lego piece, when it's printing one and it's got to go to the next part of it, it's going to have to jump a little bit, and it's not going to be printing while the printer head is jumping from one thing to the next. And if depending on a lot of different things, there may be some plastic that oozes out during that jump. Sometimes it's not a big deal, sometimes it is. So if we're noticing that we're getting all these little stringies and it just looks kind of bad, we can enable retraction, and then when it jumps from one place to the next, it actually pulls the plastic backwards, so that it doesn't drip out while it's jumping from one place to the next. There's other options, so not only can you enable it, but you can tell it how far to pull it back, what's the distance it has to travel from one place to the next in order to retract it. So there's a lot of different things that excuse me, we'll have to mess with to figure out that button if we need it. Infill, or I'm sorry, fill. So again, we have an option for the top and bottom thickness, and just like the other ones, the more thick it is, the more time it's going to take to print it. The thinner it is, the faster the print's going to be, but it's not going to be as strong or sturdy. The infill percentage, for most of our prints, we're going to want this number to be as small as possible, like a single digit. I'm still messing with it to figure out what a good percentage is. We might try 8 to start out with. Essentially, the smaller the percentage, the more plastic that we save. And right now, I have no idea if we're going to run through all of our plastic quickly or not. So the smaller number, the better, unless we're doing a final part or something that is going to need to be strong. Otherwise, we'll keep that number as small as possible. Speed and temperature, so just what you think, it's how fast the printer moves. Each printer has a different range of speeds, and again, I have no idea what the top speed of our printers are, so that's something that we'll have to play with. Printing temperature, we're going to stick with 210 degrees for the plastic that we're using, which is PLA. For the most part, we don't really want to mess with that. If there's a few things that may happen with our prints that may require us to change the temperature, but for the most part, it's going to stay at 210. And this one has bed temperature set at 60, but our beds are not heated, so it doesn't really matter. Support, this is one that we will have to change often. If we build something that has overhangs where it's not going to be supported from below, then we're going to want to add support types. So we could add supports everywhere. So if you're printing something that has a hole in it, perhaps that's going to have support on the inside. Or maybe we just want anything that's over the build plate. So if it's touching the build plate, then we'll put support there. Sometimes CURA just adds it on its own when it knows it needs it, and sometimes you have to tell it to do it. So just that'll be something that we'll get used to as we use the program. Platform adhesion. So sometimes we need parts to be exact, and usually the first layer that gets printed on a 3D printer is usually splayed out a little bit because it's being squished on the build plate. So if we add a raft is just the first layer of plastic. It is kind of like a mesh, and then the next layer prints on it and gives you a little more of an exact size, and it helps the parts stick to the build plate. So if you're building something that's got maybe like a really tiny surface area where it's connecting to the build plate, then adding a raft might be helpful. A brim is kind of like a raft, but it just circles whatever you're printing, and that's again to help regulate the size and keep it from peeling off before you want it to. The filament, we're always going to use a filament with 1.75 millimeter diameter, so we won't have to change that. And the flow rate, we'll just leave that at 100. The machine is there's a nozzle size, which is again something we're not going to change, so it's always going to be 0.4 millimeters. So I'll do another video with how to import and mess with stuff in CURA.